right, here we go. All right, one-step equations. All right. So far with combining like terms and the distributive property, we have pretty much been dealing with algebraic expressions, okay? So expression versus equation, all right? If you take a look up there at the TV, all right, that first thing that I've got up there, 2x plus 3, would that be considered an expression or an equation? That is an expression, okay? That is an algebraic expression. It's got the variable x in it, okay? Whereas 3x minus 2 equals 4 is considered an equation. That's right. And probably the biggest visual difference between the two is what does the equation have in it that the expression does not? Say it again. Equal sign, okay? So with an expression, we can simplify an expression. We can evaluate an expression, all right? With an equation, this is where we are going to solve, and we're going to find out that missing value that's going to make this a true statement, okay? So 3x minus 2 equals 4 would be an equation, and we would solve that, all right? Okay, so let's take a look at a couple of these. Now, one thing that you will see me do a little bit, okay, and oftentimes when we start talking about equations, there is talk about both sides of the equation. And you guys have heard about balancing the equation. If you do this to one side, you got to do it to the other. Well, what determines the sides of the equation? All right, and sometimes there's some confusion over that. So, you may see me do this some. Take a look at what I just did there. You may see me draw a vertical line kind of through the equal sign and on down. The equal sign is what is going to divide the equation into a left side and a right side. Okay, let me say it again. The equal sign is what's going to divide the equation into a left side and a right side. Okay, so if I were to ask what is on the left side of this equation, what would somebody tell me? X plus 4. What's on the right side of the equation? Negative 12, okay? So, and again, this seems very simplistic, but again, we need to understand left side, right side, because we will reference those sides, all right? Now, with solving an equation, we are trying to find out what x is in this case. We find the variable, or we find the variable term. The variable term in this equation is x. That is our unknown. That's what we're trying to find, okay? So we need to be able to isolate the x on the left side.
Don't you have to make it a minus that close to a minus sign
Okay,
on both sides?
there you go. Good. Okay, so right here, we're going to basically ask ourselves and say, okay, x is not by itself on the left side. There's a plus 4 over there with it. How do I get rid of a plus 4? And he said, we're going to subtract 4. So we're going to subtract 4 from the left side. And we are also going to subtract 4 from the right side because we must balance an equation. Whatever we do to one side, we have to do it to the other. Exactly. Okay? So we're going to show where we're going to subtract 4 from both sides. Of course, on the left side, those 4s, poof, they disappear. And you are simply left with x. Please, 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 always try to keep your equal signs lined up. Treat them like kind of like a decimal, okay? Try to keep your equal signs lined up. That way you keep your left side stuff and your right side stuff as orderly as possible, okay? So we subtract 4 from the left side. We are simply left with x. We now subtract 4 from the right side. What is negative 12 minus 4? Negative 16. Negative 16. Those darned integer rules, and guys, we're going to stay after the integers, okay? Same sign, keep the sign, add the numbers. Same sign, keep the sign, add the numbers. X equals negative 16 should be our final answer. Any questions thus far? Okay, now, let me remind you about something as well. And believe me, when I was your age sitting in that seat, I really didn't do this either, even though the teacher told me this, but I want you to always know that it's available for you, okay? When we find out that x is equal to negative 16, we might say, okay, I got an answer. I found out what x is. Does it work? Guys, if you are ever wondering, well, is negative 16 really the right answer? We can take negative 16 and we can go plug it back in there for x. And we can substitute it back in and say, okay, is negative 16 plus 4 equal to negative 12? Does that make a true statement? Is negative 16 plus 4 negative 12? It is. Negative 12 equals negative 12. The left side does equal the right side. That answer does make a true statement here, okay? But like I said, hopefully as you work through a lot of these, you are like, okay, good, I got it, I got it, I got it. If you are ever wondering, or multiple choice test, guys, that's a test strategy. If they give you the answers, you can always take numbers and plug them into variables and go see what happens. Okay, so it's a good test strategy as well. It's kind of plug and play, if you will. But just please always remember you can do that. I know 99.9% of the time we're not going to do that, but just know that it's available. Question? Go fast. All right, let's go over here to the right side. I'm going to draw my line there through my equal sign. That's going to divide the equation into left and right. What's on the left side? 26, right? What's on the right side? A plus x, okay? So again, getting used to identifying things on the right side and left side. What is our variable that we're solving for? Solving for x, right? Is that x positive or negative? That is a positive x on the right side. Is it over there by itself, or is there something over there with it? What's over there with the x? 8. How do you suppose we're going to get rid of that 8? Why are we subtracting it? Because what kind of an 8 is it? It's a positive 8. That's right. It's a positive 8. How do I get a positive 8 to go away? I'm going to subtract 8 because... Thank you. So that positive 8 is being added to x. So now we are simply going to subtract 8 from the left side and the right side. We are going to balance the equation. Whatever we do to one side, we do to the other. Okay? The 8's on the right side, gone. You are simply left with x. Line up your equal signs. What's 26 minus 8? What we got? 18. 18.
My last teacher, I would try to pay attention, but she's just like,
There you go. Well, we'll stay with it.
This one wouldn't you add 2 on that side?
There you go. Okay? Oh, is that a knock?
Mm-hmm.
Gotcha. All right. Hey, welcome. Hi, girl. Thank you so much. All right. Okay, so far so good?
Yes.
when she comes back. Yep.
So easy.
So far, so good? All right, let's go here. Let's grab a couple more. There's my line. Hey, welcome back. All right, we good? Like I said. All right. What's on the left side?
Oh, I got you.
What was it? Okay, good. Left side, x minus 15.
X minus 50.
Right side.
Negative 27.
Okay, negative 27. Again, guys, it seems so elementary, but be able to identify left and right side and what's there. What am I solving for?
X.
Solving for x. There it is right there. It is positive. Okay. What do I need to get rid of to get the x by itself?
Oh, easy. The numbers.
What do I need to get rid of? The 15. Is it positive or negative?
It's negative.
It's a negative 15, so therefore I will need to?
Make it positive.
Make
I
it
will need to
positive.
add it, right? Okay? So I'm going to add 15 to the left,
Add 15.
and I'm going to add 15 to the right.
Add 15.
15s cancel on the left. They eliminate each other. You are left with x equals. Okay, good. Negative 27 plus 15, different signs. Subtract. Take the sign of the larger number. And you are correct. That should be a negative 12.
Negative 12. Oh, I see.
Negative 27 plus 15, we're going to subtract the two numbers. So 27 minus 15 is 12. Keep the sign of that larger 27, so that answer is going to be negative. Okay? Everybody okay with that?
Yes. So
It is. And like I said, I hope that it is. I hope that I hope we look at this and say, gosh, this is pretty simple. Awesome. It is. But guys, these are, these types of equations, I mean, if we get these need to be automatic. Okay? All right? In baseball, at least, I'm pretty familiar with baseball, or it could be football or whatever. But in baseball, oftentimes we tell our players, hey, we have to be able to make a routine play. If they hit a little pop fly to you, if they hit a little ground ball to you, we have to be able to make the routine play. All right? That's what this is. This is the mathematical equivalent of a routine play for you guys. If we get a one-step equation like this with addition and subtraction, guys, we need to be able to get it pretty quick. Okay, we need to look at it and say, I know what I'm doing. Boom, boom. Got it. Routine play. Okay, over here, right side. Right side's 23. Left side? 15 plus x.
But we do subtract x or we do subtract 15.
Well, identify your variable, right? What are we solving for?
X.
X, and that x is by itself. It's positive. So what do we need to get rid of to get the x by itself? 15. Is the 15 positive or negative?
Positive.
So what do we need to do?
Negative.
Okay.
Correct.
We're going to subtract 15 from the left. We're going to subtract 15 from the right. 15's gone.
23 minus 15.
X by itself equals 23 minus 15.
8.
8 is a winner.
Yeah.
8 is a winner. Okay?
Coach King, I went ahead and did it. I got it right.
Good job. Excellent. Excellent. Okay? Guys, a lot. Do I know? Yes. Guys, a lot of being successful in math is being able to ask yourself the right questions. Okay? Students oftentimes, I hear it all the time, and you've probably said it. I hear it all the time. It's so much easier when I'm here in class with you. When I get home, I can't do it by myself. Well, guys, here's part of the issue, and it's not, you're completely normal. What's going on is that when you guys are in the room with me here, I prompt you with questions, okay? Part of the key to being successful with a lot of math is just you being able to ask yourself some of these questions that I ask you. What's the variable? X. What else is over there with it? 15. What kind of a 15 is it? Positive. What do I need? How do I get rid of a positive 15? Ooh, I need to subtract 15. So I'm asking you these questions. A lot of times when you get by yourself in a different environment at home or whatever, what you're having trouble with is you're having trouble asking yourself those questions, okay? So again, it's that prompting. And you being able to ask yourself the questions a lot of times is what helps you get through the problem. So when you get something and you're kind of by yourself or you start working independently, just start asking yourself questions. What am I solving for? What do I need to get rid of? How do I get rid of it? Okay? What's on the left side? What's on the right side? A lot of these questions I'm asking you need to be a lot of the same types of questions you can ask yourself. So guys, I mean, it's completely normal, but I really believe that's kind of what happens. All right, let's take a look here. We're down the home stretch. Still got our equation. I'm going to draw my line. We're going to define the left side and the right side of the problem. What's on the left side? 21. What's on the right side? Negative 7x. Okay, so let me ask you this question. What's going on between the negative 7 and the x? Is that negative 7 plus x, minus x, times x, divided by x? Is what? Say it again. It's times, right? Guys, multiplication is one of those operations that doesn't necessarily need a symbol. Guys, if they're adding, we've got to show you a plus sign. If we're subtracting, we've got to see a minus sign. If we're dividing, we need to see some type of division symbol. Multiplication can be understood. That's what's going on right here with this negative 7 and the x, is that is multiplication. What are we solving for? Say again? Say it out loud. X. Say it with confidence. X. We're solving for x. What do I need to get rid of to get the x by itself? What kind of a 7? Okay. Now, if negative 7 and x are being multiplied together, what undoes multiplication? Division. Division. Okay? So, if negative 7 is being multiplied to x, we are simply going to divide both sides by negative 7. Negative 7 divided by negative 7 is a positive 1. Guys, when we get that variable by itself, we need a positive 1 in front of it. So when it comes to multiplication division, you are going to multiply or divide by exactly the number that you see. Because any number multiplied or divided by itself is a positive 1. Let me say it again. Any number divided by itself is a positive 1, not necessarily multiplication. What's 21 divided by negative 7?
3.
Say again?
Negative.
Okay, good. Positive divided by a negative, always a negative. X equals negative 3. X equals negative 3. And again, if you're not sure, plug it back in. Is negative 7 times negative 3 equal to 21? Absolutely. Negative times a negative, always a positive. Are we okay with this?
Yeah.
Question? Okay.
Can I go to the bathroom or something?
Yes. Okay? All right, let's go over here on the right. Now, here's my line. What's on the left side? Say it again. X divided by 8. That little bar there, that little bar. You guys, I'm fairly certain that you guys recognize the left side as a fraction. Okay? That little bar can be understood as division. That is x divided by 8 equals 2. So on this one, again, what are we solving for? Solving for x. There it is. If x is being divided by 8, what undoes division? Multiplication. So if we're dividing x by 8, we're going to undo that by multiplying both sides by 8. Now on the left side, watch what happens here. Those 8s disappear. And you are simply left with x. On the right side, 2 times 8? Yep. 16. Okay? So again, visual recognition of what's going on. Do we have addition, subtraction? Do we have multiplication, division? Okay, so that's going to be very important that we have that awareness, that visual awareness to recognize what we're looking at and how we're going to undo it. Okay? What am I solving for? What do I need to get rid of? How am I getting rid of it? There's those questions that we need to be asking ourselves. Any questions on these two here before we go to the last slide? So far, so good? Yeah, when she gets back.
Yeah.
All right, here we go.
I'll fill it up.
Last couple right here. All right. What's on the right side? Okay, -3. All right. What's on the left side? -x divided by 2. Now, listen carefully here. On the left side, you see that negative sign. That negative sign is kind of in the middle of that fraction, okay? Anytime the negative sign is in the middle of a fraction, that negative sign can either be associated with the top or the bottom. One or the other, not both. Okay? So probably what I would do is I'm going to associate it with that 2. Okay? So that negative x over 2, I'm going to kind of look at this as x divided by -2. All right? So when I go to solve this, what the heck? I'm not getting any erasure there. Okay, that's all right. Okay, so what am I solving for? X. What do I need to get rid of? -2. There you go. I'm going to multiply. I'm going to multiply both sides by -2. Let's get rid of the negative and the 2 in one shot. Okay? That negative sign in the middle can either go with the top or the bottom. I'm going to put it with the bottom number of the 2. So now when we multiply, I can get rid of the negative and the 2 in one shot. Gone. X equals +6. -3 times -2, +6. Okay? Everybody okay with that? Watch out for those negatives, but sometimes when that negative is in the middle of that fraction, a lot of students that think it belongs to both items, and it does not. It's one or the other. It's really your choice, but I would always tend to put it with the number if I can. I think it's just easier. Okay? All right, let's go over to the last one. 6 equals x divided by 10. What are we solving for? X. What needs to go away? And how's it going to go away? There you go, multiplication. That's right. Let's multiply both sides by 10. If x is being divided by 10, we're going to undo division with multiplication. Right side, 10's gone. X equals.
60.
And 10 times 6? I like it. 60. Please, please, please keep your equal signs lined up. Keep the variables on the side that they are on. Keep everything, just keep everything on its respective side unless you move it to the other side, okay? I see a lot of students that they start moving their variable around for no apparent reason, and it creates a lot of confusion sometimes, okay? Keep your equal signs lined up. Keep the variables on their respective side unless you move it, okay? But just try to stay orderly on your paper, all right? Stay organized. Okay, questions? Any questions? Should just be a refresh of some one-step equations, but like I said earlier, guys, these are routine plays. When we see an equation, especially of the one-step variety, we need to see it and go, man, I got this. I can do that. That's easy. Boom, boom. I got it. Okay? That is the routine play. We need to make the routine play. All right, no questions? Okay. All right, before we get you going here, let me say this. Let me see everybody's eyes. Let's see, I don't have our social contract up yet, but active listening. I'm already, just grabbing these couple papers today, I'm already starting to kind of see it. With a lot of students, the problem isn't the math. The problem is not the math. And you remember that first day I taught you guys, I showed you a picture of an iceberg? You remember that? And 7/8 of the iceberg is underneath the water. And there's a lot of things underneath that water level. Guys, a lot of the success that you can have with math isn't going to be about the math. It's going to be about you getting started, doing a lot, creating a good routine, creating some good habits, okay? Doing little bitty things like I would imagine. I didn't collect a whole lot of papers today. So that means we've got several people that don't have things done, okay? And guys, that's not a math issue. That's a routine and habit issue, okay? You need to utilize this time. Yeah, we're going to do some math, but guys, again, let me reiterate, you have a chance to start building good routines and good habits and a work ethic. You have the ability to start working on those types of things that will serve you in any part of school or life, okay? So when we start this here in just a minute, you need to get started. Start with the first problem. Accomplish the first problem. Then move to the next problem. Accomplish the next one, okay? And just start building those routines and habits. That's the issue for a lot of you. It's not the math. You can do the math. It's just you deciding you want to do it, okay? All right, I think in Canvas, it should be loaded in there, okay? We are going to do the evens. We are going to do the evens, okay? One-step equations. You're going to accomplish the even numbers today. Question? Okay?
Is it this?
Should be in there. Yep. It's 823, one-step equations. That little worksheet should be loaded in there digitally for you. We're going to do the evens, okay? I would go ahead and encourage you to write the problem. Write the problem down and go to work on that problem, okay?